In this video, we're going to be talking about the layers of the sun and the features of the sun. There's 6 different layers of the sun, 3 inner layers and 3 outer layers. We're first going to be talking about the innermost layer, and also known as the hottest layer, which is the core. This is the hottest layer. The core is the hottest layer of the sun, and possibly the hottest layer, hottest part of the entire solar system. This basically contains almost all of the sun's energy, and matter of fact, it's so hot that hydrogen turns into helium. When hydrogen turns into helium, this process is called nuclear fusion, and instead of turning into a state of matter like solid, liquid, or gas, it is actually in a state of matter of plasma. Now we'll be moving through the plasma, and plasma is very important towards the end. However, first, what happens is whenever the energy is released, it's released in the light energy, and by releasing it in the light energy, it then moves on to the radiation zone. What happens is when the photons, which is basically a particle of light, they bounce off each other. By bouncing off each other, they create some kind of zigzag kind of pattern. This zigzag kind of pattern makes it radiation. So if you're wondering what radiation is the process of heat or light moving through a vacuum, and it does not require having to be moved through a medium. So basically, it is radiating through the radiation zone. So here light is made up of photons, which is a particle of light, and they're bouncing off each other or radiating off of each other, and are moving through the radiation zone. However, this radiation zone basically takes like a very long time. Around 50 million years it takes for the photons to travel from the core to the next layer called the convection zone. Also, this process of light radiating is known as electromagnetic radiation. And now this plasma that we talked about, in this area of the radiation zone, this is where it develops its first magnetic field. So the magnetic field of the sun is very important. Next, we're going to be talking about the convection zone. As the name implies, convection, if you don't know, is basically where hot matter below rises at the top and cold matter at the top comes to the bottom. And the reason why this happens is because the cold stuff is more dense than the hot stuff. So hot stuff rises, cold stuff sinks. Then when it goes over here at the top, this turns cold and it goes back to the bottom. This turns up. This is more heated because it's near the core, so it rises to the top. This is called the convection zone, and it typically just takes like a few months or a couple of years for the photons to be able to travel to this. Also, speaking of photons, the photons is transferred from light energy to heat energy. So what happens is this heat energy is going through this convection process until eventually it enters into the photosphere. So now that we're done with the entire inner layers of the sun, we're moving on to the start of the outer layers of the sun. So the photosphere, as we see over here, is, as the word photo means light, it is the most visible part of the entire sun. And that's because light and heat, because the convection zone is more dense compared to the photosphere, and the photosphere is less dense, the light and heat is able to easily escape from it. And because of that, because it easily escapes, that's why on Earth we're able to receive both light and heat from the sun. Next is the chromosphere. Chromo means color. So at this point, the plasma, whatever is here, becomes transparent, and because of that, we're not able to see it with our naked eye without using any special tools, or during a solar eclipse we can see the chromosphere. But other than that, the plasma becomes transparent and we're not able to see it because the light from the photosphere is too gray, and because of that it overshadows the chromosphere. And the same thing can be said with the corona. The corona is much more hotter compared to the photosphere, and this, however, it is also overshadowed, as this is where the light comes from, and it is overshadowing the corona. However, you can see the chromosphere and corona only during one time, and that one time is either using special equipment or during a solar eclipse. During a total solar eclipse, the moon covers this entire part, and because of that, we're left with the chromosphere and corona, so we're able to see that. This is also called the sun's crown. All right, so now you might be wondering, how do some special features such as sunspots, solar flares, or maybe even prominences happen? Well, it all has to do with the plasma that has been created. So sunspots are located in the photosphere. What happens is that this area where the sunspot is much more cooler compared to the rest of the area of the photosphere. And because it is much more cooler, it is much more denser also, because cold things are much more denser. And because it's more denser, it does not allow photons to travel out or escape that easily. And because of that, it appears very dark compared to the rest of the photosphere, because the light is escaping very fast. What happens is that it is brightening up compared to this part over here, making it seem darker. And also, since it's cooler, it also makes it seem darker. Then we have a solar flare. This is a sudden burst or a release of energy in the chromosphere, is caused by the entanglement of the magnetic field. So what happens is that because of this sudden burst, heat and light escape through very quickly. So the light escapes through, but the heat, due to the sun's gravity, comes back. So when the heat comes back, the light still escapes. And because this this energy along with the light is being released, this energy causes the satellites located near our atmosphere to stop working. And because of that, it can cause major power outages. And lastly, we have a prominence. A prominence is a huge cloud of gas that rises along with the magnetic field. So since it rises along with the magnetic field, light and heat rises along with it too. And basically, it extends so far out of the sun soon is not able to obtain this prominence, because it's too far out for its gravity to control it. And because of that, eventually the magnetic field just releases the heat and the light. Also in the photosphere, the light that's being released in the photosphere, it only takes 8 minutes from the photosphere to get to Earth. Now, for other planets, it could be different, because Mercury is much more closer to the sun, but something like Neptune is way farther off. So the amount of time it takes for light to reach there is at different times. But for Earth, it takes 8 minutes. So let's say, for example, the sun magically disappears. It would take 8 minutes before we realize, and we would get no light. Also, in the core, hydrogen makes up 3/4 or 75% of the entire core, while helium makes up the rest. Together, the core and the radiation zone make up 70% of the entire sun. And if we take the entire sun, the sun's mass itself takes up around 99% of the entire mass compared to all the other planets. So 99% of the mass in our solar system is made up of the sun, and the other 1% is half of it is from Jupiter, and the other half is all the other planets.